Now that we come to adding and subtracting with these radical expressions, we end up falling back on something that's already in our toolbox, and that's the idea of combining like terms. We need to make sure that we are very clear about what would be like terms, though. And so what we have going on here is something very specific. There are two key elements. We have to have the same root, and we have to have the same expression underneath the root, aka the radicand, as the official term for that. So when we talk about adding and subtracting, we can only add and subtract with our combining like terms idea if we have the exact same root appearing in those expressions and the same exact thing inside of those roots. So here, a couple of different variations. 5 square root of 6 minus 8 square root of 6. I have both of these with a square root and both of them with a 6 underneath. These are like terms. We can put those together like we would in the past by looking at what's out in front. I got a 5 and an 8. I got a minus in between them. 5 minus 8 give me a negative 3, and they would still have to both have that like term element of the square root of 6 showing up on that final answer. 2 square root of 3 minus 2 cube root of 3. Well, if I'm literally saying it out loud, it's a lot quicker for me to hear the difference that is in this particular problem. The first term has a square root, the second term has a cube root. Can't have those being combined together because they're different roots. It doesn't matter that they both have a 3 underneath. They're different roots. Things fall apart. Cannot combine those. 7 cube root of 2 plus 3 cube root of 4. These are both cube roots, but again, if I'm listening carefully and thinking about both qualifications, yes, these have the same root. They both have a cube root. But when I'm reading through, the first one has a 2 in the cube root, and the second one has 4. Those are different things in those cube roots, which means that these are different. Yes, they might be related, but they're different, and they're different enough that we cannot combine them together. So also, not possible. These are not like terms. And if we have some more terms than just simply 2, then still the same idea holds. As I'm working through these problems, the terms that have the same root and the same expression inside the root, those are things that can be combined. All 3 of these terms have a square root with an xy underneath, so these can be combined together. 5 minus a 3 plus a 7, still have to have that square root on my answer, so I get a 9 with the square root of xy. The extra little twist to these problems that have radicals is that it is not always immediately apparent, certainly not as quickly apparent as it's been for us in the past, whether we have like terms to combine. And this example will hopefully illustrate that idea. If I look at this problem without thinking very deeply about it, the square root of 75 plus 2 square root of 3, first term has a square root, second term has a square root, but there are different numbers underneath. So without thinking about things, I might just automatically say, these have different numbers under the square roots. I cannot combine these together. But if I did that, I would be wrong, because as we've seen in the past, sometimes we have radicals that can be simplified, and if we don't consider simplifying the radicals in our problems, we might miss being able to combine like terms, which therefore makes us officially incorrect. So we would want to make sure that we're carefully looking at things and saying, well, all right, what about that square root of 75? Is there anything that I can break off of a 75 that has a nice square root? Yeah, there's a 25. I'll break off that square root of 25, give me a 5 out in front, and leave me with a square root of 3. Now this problem has been transformed so that it would be a 5 square root of 3 plus 2 square root of 3. It was hidden from us originally, but it turns out that we do have like terms. These can be combined to give us a much nicer, shorter, simpler answer, 7 square root of 3. So, little comment here about adding and subtracting problems that's very important for us to keep in mind. Before we actually decide that we are done or cannot do any of our adding and subtracting that shows up, we want to make sure that each individual radical has been completely simplified based on the rules that we had in our earlier video. So again, when I look at the problem, we have square root, a square root, and a square root, yay, but each square root has a very different expression underneath of it. So that very first reaction is these do not appear to be like terms. Now I don't want to stop there though. I want to make sure that I simplify each of these 3 radicals as much as possible. So I want to look at each of these and see if there's anything that can be done that might allow me to come up with 2 or possibly even all 3 being like terms. So as we go through, we've got that first square root where the square root of 2 and the square root of y cubed can be broken apart. The square root of y cubed, according to our shortcut, power of 3 divided by 2, because this is a square root, would give us a 1.5, meaning a y with a power of 1, and a 1/2, meaning a square root of y would still be appearing. And our square root of 2, which was there, and in fact our -3, which is also at the very beginning of all of that, all coming together to give us a more simplified answer of -3y square root of 2y. In the second term, we have a square root of 18y. So we would begin by breaking that apart, where we would have the square root of 18 separate from the square root of y. The square root of 18 can be broken apart as the square root of 9 times the square root of 2, which means that we would want to have the 3, the square root of 2. There's also the square root of y that we broke apart earlier. We don't want to forget about that. And when we do put things together, we also have the 5y out in front of all of that, which means that a simplified version of the middle term would have the 5 times 3 is 15, the normal y, and the square root put back together so that it's a 2y underneath. Our first term and our second term, we've now found, are in fact like terms. What about that third term? Let's see how that one might play out. So in that third term, we begin by breaking our square root apart so that we have our square root of 50 separated out from our square root of y cubed. Our square root of 50 can be broken apart as a square root of 25 times a square root of 2, meaning we've got a 5 times a square root of 2. The y part, we would need to take our power of 3 divided by 2, and we get that 1.5. We might have in fact also remembered that we had that from our work a few minutes ago, and that means that overall we've got the 2 out front, we've got the 5 square root of 2, y square root of y, And then this would all come together. We've got the regular 2 times the regular 5 giving us a regular 10. We've got a regular y, and then we've got our square root stuff that we can put back together. Square root of 2y. Minus sign in front of that. Actually, all 3 of these terms now are in fact like terms. They all have a square root with a 2y underneath. So we can put all of these together by doing the negative 3y plus 15y minus 10y. And just to make sure that we don't lose track of any of that stuff, we can go ahead and actually write in that step like so. The negative 3y plus the 15y minus the 10y. And they all have that like term portion of the square root of 2y. And this would give us as our final answer a 2y square root of 2y. So again, going back to that earlier comment at the top of the screen in red, before you do any adding or subtracting or decide that you cannot do any adding or subtracting, make sure that each individual radical has been simplified as much as possible so that you can say with greater certainty that you do or do not have like terms. If you do have like terms, you combine them together. As long as you've got the same radical, the same root, as well as the same expression underneath those roots, then you do have like terms, and you can combine those together in order to get a shorter and simpler answer.